omega AP and the YP dot. I want you to look at I used a box to highlight the answer for omega AP and the YP dot. I only highlight the symbolic solution, as you can see here. I want you to do the same thing in your homework. Just highlight write everything in symbol and solve the symbolic solution first, and use the box to highlight the symbolic solution. Then after that, plugging all the numbers to get a number for your Moodle online homework. Because this symbolic solution is all I care about. I want to make sure you understand the process, how to solve everything. All right, now let's move on to accelerations. Since we still have one more unknown to solve, so now we can set up equations for acceleration. Okay. First equation we can get is the equation we learned from chapter 3. It's the equation AP and the fixed point AO plus AP slash O relative plus alpha cos RP slash O plus 2 times omega cos VP slash O REL relative. We're not done yet. One more term, that is minus omega square RP slash O. Okay, this is the equation we learned from chapter 3. Let's working on this expression. So AP equals 0. A is a fixed point, so it has 0 acceleration. 0 plus the AP slash O relative. We did that as step 5. So AP slash O relative is YP double dot. Okay, so here we have plus YP double dot. Keep it in mind, we need to have a direction for this. So that direction is small j. Okay, then plus alpha. Alpha is the unknown we try to solve, but here, since this equation has come from the rigid body OBE, the L-shaped bar, and the moving particle. So this alpha should be the angular acceleration of the L-shaped bar OBE, which is the unknown we try to solve. This is on K direction. This will cause and RP slash O. RP slash O is a position vector from point O pointing to point P, and that we know the distance from O to B, that is our I direction. So here we have that is our B, positive B on I direction. And in terms of J direction, the distance is given YPJ. This is our position vector RP slash O. Let's go back to check if that is right. So YP slash O, starting from point O, pointing to point B, and the I direction, the distance is B. The Y direction, the distance is YP. They're both positive, so we're good here. Okay, we're not done yet. Let's keep working on this. And here we need to plus 2 times omega. Omega here, this omega, it's the omega of the rigid body OBE, which is this L-shaped bar. And we know the omega in terms of omega, that's a value. K is on K direction. This cross product, course, with the velocity p/o relative. We know that is yp dot on j direction. So here we have yp dot on j direction. Good. Then we minus omega square. This this omega we know it's omega square times rp/o. Here rp/o is the position vector, same as the rp/o here. So these two position vectors are the same. So we can just copy what we got here. So it's bi plus ypj. Okay. All right. Now we can arrange terms to write AP in terms of something I plus something J. Okay, so AP can be written as, I think we need to break down the cross product. So K cos J will give you positive I. So it's 2 omega yp dot I. Alright. Oops, excuse me. I think we're missing some terms here. Alright, we need to copy yp double dot j, small j, plus we need to break down this cross product first. So ki will give you negative j. So here we negative alpha b, that's your small j, and k cos j will give you positive I, so we have plus alpha times yp I. Okay, now plus, moving down here, k cos j will give you positive I again. So here we have 2 omega yp dot, that's I direction, minus, here we end up with omega square bi minus omega square ypj. Okay, now we have 3 j terms and 3 I terms. Let's combine them. Then we end up with, for all the I terms, we have alpha yp plus 2 omega y dot yp dot and minus omega square b. So this is our I component, and let's plus our j component. Our j component, we have yp double dot minus omega, that's alpha, sorry, times b, minus omega square yp. This is our j component. Okay, now our AP is written in terms of something I plus something j. So far we have our first expression for AP, and just like what we did for velocity, we need to look at the rigid body PA and to build another equation. So let's do that for the acceleration. Alright, rigid body P. And we have expression from chapter 2, AP equals AA plus alpha cos RP RA's RP slash A minus omega A P RA slash P. Okay. Here I want you to pay extra attention to the alpha and omega here. Since we established this equation from this rigid body PA, therefore the acceleration alpha and omega here should be the acceleration and the angular velocity for the rigid body PA. Therefore, make sure you add a subscription. This is for PA. Yep, or AP. Let's keep that consistent. AP. Okay. Right. A is a fixed point. It has 0 acceleration. Alpha AP is the unknown we try to solve. It's on K direction. This cos RP slash A is a precision vector pointing from A to P. And we did that in the velocity equations. So we have negative square root L square minus YP square. This is on I direction. On J direction, we have YPJ. And minus omega AP in K direction. And excuse me, I think here I made a mistake here. So this is not correct equation. Let me fix this. The correct equation should be, here should be omega AP square times RP slash A vector. Okay. So omega AP here, it's a scalar instead of a vector. Okay, RP slash A, it's the same, we copy that. Okay. And then all you need to do is to do the cross product. Okay. Let's do it. So we end up with negative alpha AP square root YP square. K cos I will give you positive J. Okay, then K cos J will give you negative I. So here we have negative alpha AP YP minus plus omega AP minus omega AP YP. This is J. Okay, then we can combine terms, combine all the I terms and J terms to find out AP is negative alpha AP YP plus Okay, this is all on I direction plus okay. So far we have expression for AP in terms of big I and big J. And now we can equals all the I components and J components in terms of between. Let me zoom out. Here we have equation for AP here, another equation for AP here, and we can assume I equals I, J equals J. Just at this moment, then we can break down all the I components. So for the I components here, we have copy alpha A P Y P plus omega A P square root L square minus Y B square. This equals to the I component, which is alpha yp plus 2 omega yp dot minus omega square b. Okay, this is the I component. For J component, we have negative alpha ap yp minus omega ap yp equals to the I components on from the first expression, which is yp double dot minus alpha b minus omega square yp. Okay, now you have two equations, equation 1, equation 2, and it should be a simple task to apply these two equations to find out an expression for the unknown alpha ap. So this is the only unknown we're looking for, and Vp, it's given omega ap we solved, which equals to omega, and we know L, we know YB, this is alpha AP, this is unknown here, we know YP, we know omega, YP dot is solved, so here alpha AP, it's the only unknown we need to solve from the equation 1. And the equation 2, we have, this is our unknown, alpha AP. We know YP, we know omega AP, we know YP. This, it's unknown, YP double dot. We're not looking for YP double dot in this problem, but if this is exam, I could ask for what is YP double dot, and now you know how to solve that. And the rest of all the givens, right? I believe you can apply the first equation here to solve what is alpha AP.